So 2.5 talks about analyzing graphs. Talks about analyzing graphs. So one way we're going to analyze them is to see if the functions are even or odd. It is possible for them to be neither, even or odd. So if it's even, then you have the points x, y, but also opposite of x, y. That's on your graph. So the rule is if you plug in negative x into your function, you get out the exact same function. That's what makes it even. And then if it is even, then it has y-axis symmetry. So remember, symmetry is like a mirror image. So the y-axis would be your line of symmetry, your mirror. And so if you folded over that, then the two parts of your graph would just be one. They would lay on top of each other. So what I have underlined are the main parts you need to know. Okay, so if it's an even function, then f of negative x equals f of x, and that gives you y-axis symmetry. Okay, so we will use the rule to see that this is an even function. Okay, so I'm wanting to test if f of negative x equals f of x. So if I plug f of negative x into my function, okay, so I'm just plugging in a negative x where I see an x. So think about that. We talked about that a little bit yesterday too. So negative x squared is negative x times negative x. That's negative times negative is positive, so positive x squared. So I can rewrite that as positive x squared plus 2. So does that give me the exact same as what I started with? Yes. So therefore it is even. And it has y-axis symmetry. Okay, we're going to sketch the graph. Tomorrow we will be using the graphing calculators to help us sketch the graphs, because in this section we're just doing basic sketches, okay? And we're going to learn a lot more about the graphing in 2.6. But for right now, for 2.5, we're just doing basic sketches. But this is one that we can graph this. We don't need the graphing calculator. Okay, first of all, let's just go back and talk about what does the graph of f of x equals just x squared look like. Okay, so that's a quadratic. That's the parent function of a quadratic. So it's a parabola. You start at 0, 0. And so if you plugged in 1, 1 squared is 1. If you plugged in negative 1, negative 1 squared is 1. If you plugged in 2, 2 squared is 4. If you plugged in negative 2, negative 2 squared is 4. Okay, and that will be good enough. But if you plugged in 3, 3 squared is 9. Okay, so in general, the rule with parabolas, as long as you don't have an a value, you don't have a number in front of x squared, then you can use just the squaring pattern. So starting at your vertex always, if you go over 1, 1 squared is 1, so you go up 1. If you go over 2, you go up 4. If you go over 3, we go up 9. And vice versa, if you go left 2, up, you go up 4. Okay, so now let's look at x squared plus 2. So who remembers, what is this plus 2 going to do to this graph? Yep, it's going to move up 2. The whole graph is just going to move up 2. So again, if I start my vertex here now, moving up 2, I'm still going over 1, up 1, left 1, up 1, over 2, up 4, left 2, up 4, and so on. You always go back to your vertex when you do that. Okay, so that's the graph. Again, it's just a sketch. This is actually a better sketch than what you really even need to do with this. You don't need specific points here. We just want to sketch it so I can see this symmetry. So y-axis symmetry, there's my y-axis, and I'm looking at the green graph now. So I can tell that this is symmetric on that line. If I were to fold over that line, then this would become just one graph. Okay, it would lay right on top of it. Okay, does that make sense? Okay. The main thing is that you can test algebraically to see if it's even or odd, which we're going to do in a minute. Okay? All right, let's look at another one. I'm not going to worry about sketching the graph here. Okay, if I want to show that it has y-axis symmetry, then I'm going to show that it's an even function. So to show that it's an even function, I have to show that g of negative x equals g of x. Okay? So let's plug that in. Plug in negative x. Okay. So just like with the x squared, the negative x squared, let's look at the negative x to the fourth. Okay. So I have x to the fourth, and then a negative times a negative times a negative times a negative is positive. So I just get x to the fourth. So if you have any even power, then the negatives become positive.
So anything with all even exponents would just be.
Right, it's just, well, anything with all even exponents, yes. Or even exponents and a constant, that's not going to change. So if you have an even exponent, it's going to just be 3x to the fourth, okay, because that negative x to the fourth is just x to the fourth. And then this is just x squared, so minus 2x squared. It's not this negative and negative together. Remember, exponents come first. So you have to do the negative x squared, which is x squared, and then that's multiplied by negative 2. But they have to all have negative, or all have even exponents. All right, so is this the exact same as my original function? Yes. So therefore it is even and it has y-axis symmetry.
You have to graph it.
Not unless it tells you to. There's questions that just ask you to state whether it's even, odd, or neither. So in that case, you wouldn't have to. Okay. All right, we're going to talk about odd functions. I'm going to show you the graph of an odd function here in just a minute. So a function is an odd function if and only if you have x, y, you also have the opposite of x and opposite of y. So now this is the rule. F of negative x gives me negative f of x. That means if you plug in negative x, you get the exact opposite of the whole function. The opposite of the whole function. Then it has origin symmetry. So that means it has rotational symmetry, like 180 degrees. Right, 180 first. I'll show you what that looks like. So about the origin. So you start at the origin, you can rotate it 180 degrees, and that is where the symmetry is. That's where your two parts will overlap. Okay, so first of all, let's talk about opposite of f of x. So if I want the opposite of h of x, then I need the exact opposite of this. So every term is its opposite. So I would want a negative cube root of x and a positive 2. Okay? So let's plug in negative x. We only have one place to do that. I need to talk about this though. So cube root of negative x, okay, that's the same thing as the cube root of negative 1 times x, correct? Okay. So I know my radical rules say I can then separate those. And the cube root of negative 1 is negative 1. And cube root of negative 1 is negative 1. So I get negative 1 times cube root of x, which is negative cube root of x. This doesn't work with square roots or any even roots because you get imaginary numbers. So if you have an imaginary number, then you know that you can't just pull out a negative. That's not going to work. If you have any odd power or root, then you can pull the negative out. The negative stays with it. So this was cube root. Let's look at this. And this isn't part of this problem, but I just want to talk about these. So if you were cubing something, or if you have an odd power, negative times the negative times the negative is negative. Okay? So if you have an odd power or odd root, you can pull that negative out front. It's going to stay negative. If you have an even power, it becomes positive. If you have an even root, then you get imaginary numbers, and that just means it's going to be neither, not even or odd. Okay? Okay, so that being said, I have an odd root. That means I can pull out the negative. Nothing with the 2 though, so that's just still minus 2. So I'm looking to see if it's odd. Is this the same as this? No. So it's not odd. Okay. Let's see then. Well, okay, if it's not odd, is it even? Is this the same as this? No. So it's not odd. It's also not even. So if it asks us to say, is it even or odd or either, in this case, this function is neither. That's not the same. So it's not odd. And that's not the same. So it's not even. Therefore, it's neither. Yes.
As far as like the math goes, but like with the graph and stuff, how can it be neither? Like how is that X?
So the graph just means it's not, it doesn't mean that it's not symmetric anywhere. It just means it's not symmetric over the y-axis, or it's not symmetric about the origin. And the reason why this one is not is because you're shifting, the way you're shifting it, then it's not going to be, it's going to be like, okay, so this graph ends up looking something like this. And that's a really bad graph. But it's not symmetric about the origin. So
it's not that it's like actually neither, just in this case for the y-axis symmetry.
yeah, it's neither because it's not symmetric over the y-axis or the origin. But it's still symmetric over its inflection point. But for even or odd, it has to be just those two. And again, tomorrow, once we actually are graphing some of these on the graphing calculator, we'll be able to see. Okay, so I want to look at another one. And I am going to show the graph of this one. Okay, so plug in negative x. So for even or odd, you're always testing negative x. If you get the exact same, it's an even function. If you get the exact opposite, it's odd. If you get some that are the same, some that are opposite, then it's neither. Okay. So negative x cubed. It's an odd power, so that negative can be pulled out front. Same thing with negative x to the first, that negative can be pulled out front, which then makes that a positive 7x. But think about just your multiplying here. You don't have an exponent, so you go right to multiplication. Negative 7 times negative x is positive 7x. Okay, so is this the exact same as the original? No, so it's not even. Is it the exact opposite? Yes. So, therefore, it is odd. And it has origin symmetry. And this is what the graph looks like. So if you were sketching that, you would really just draw a quick sketch. Draw your axes, draw in the sketch. So origin symmetry means you can rotate 180 degrees over this origin, over 0, 0. So if you rotate that around, okay, then you would have a mirror image. It would lay right on top of that other one.
When you graph that, do you use the one, the original function, or the one you came?
You always use the original. Yeah.
Is the new one the?
The new one is just us saying, okay, if you get the opposite, then you know it has this type of symmetry. Okay, so these graphs are the graphs of the originals. Okay. Okay, we're going to talk a little bit about these inequalities. So I'm still analyzing graphs here. Now I'm going to talk about where it's positive or negative. So we use the graph to help us with this. So here's my function, and here's the graph. So I could solve this function, I could find the zeros and solve this inequality that way. But if I have a graph, I can just look at the graph. So I want to know where f of x is greater than 0. So remember that's y is greater than or equal to 0. F of x means y. So I'm looking for where y is greater than or equal to 0. Okay, so my x-axis here, this is where y is 0. Okay, all across here. So greater than or equal to would be above that x-axis. Well, I only have this, and there's an arrow there, so that's continuous. That's above. But since it's equal to, I have this point, and then I have a point here. So those are the places. Okay, solving inequalities, we write intervals. So our answers, we look at y, but we write our answers in terms of x. Okay, so we're writing the intervals of x. So it's greater than or equal to 0, where x is negative 2. And then also from 2 to infinity. So to write that in interval notation, we have that it equals negative 2. So it just looks like that with your brackets. And then I also have 2 to positive infinity. And that's it. That's my whole answer. I want to practice this just a bit more. So this is the answer to this question. But what if it had asked us, find f of x where f of x is less than 0? Okay. Well, first of all, it's not equal to. So here, these places where it equals 0, those are holes. But I have all of this that's below. I have a hole here, so I have negative infinity to negative 2. And then I start back at negative 2 to 2. Then the rest of the graph is greater than 0. So I have negative infinity to negative 2, negative 2 to 2. All parentheses because I'm not including those zeros. Questions about this one I have in blue? So we're looking at y, but then we write our answer in terms of x. Okay? And then let's just do, okay, if it's less than or equal to 0. So this time I want to include these points. So I have negative infinity. That part's included, so I don't have to stop there. I have negative infinity just to 2. Since that's included, there's not a hole, I don't have to stop. Questions about that?